Hello again, welcome to video number 4 on the Introduction to Calculus. Before we start, some little warm-up questions. These are skills you're going to need for this video. So please pause, have a look at these questions, see what you can do. We'll go through the answers when you come back, and then we're going to move on to our proof about differentiation. You're going to love it. Alright, you've had a go at the warm-up now, so if you didn't pause and do the warm-up, do that now. Here's some answers. Now, I've told you what the function of x is, and I've just asked you to find the function of 5. So you simply needed to put 5 in here. So 5 squared is 25. That'll be 25 plus 3 times 5, which is 15. So our answer is 40. Then I asked you for the function of x plus h, which means put x plus h everywhere you see x. So that would be x plus h squared plus 3 lots of x plus h. You could leave your answer like that, or if you wanted to, you could expand it. You'd do that very carefully. You'd make that x squared plus 2xh plus h squared plus 3x plus 3h. Question number 2 asks us to find a limit as x approaches 0 for x squared plus 5. Now I can find this limit easily because I can just substitute that 0 in there. So this would equal 5. 0 squared plus 5 is 5. However, it's not so easy to do that in question number 3 because when I try and substitute x in here, oops, sorry everybody. What I'm doing. Yeah. When I try and substitute x in here, I'm going to get a 0 on the bottom of this fraction, which is undefined, so that's not going to help me. So what I first need to do is I need to tidy this up. I want the limit as x approaches 0. I've got a common factor here. I can cancel those out, and now I can substitute the 0 in, and I will just get an answer of 7. So we did a little bit of limits first part of the year, and I'm just trying to remind you of that. All right, let's go back to our calculus. You will remember that we have been working a lot with the y equals x squared plus 3x. And in one of our very first lessons, we said that we wanted to find the tangent right here at this point. And to do that, we needed 2 points. So we kept finding points that were closer and closer to 1, 4. And we saw that the gradient was getting closer and closer to 5, so that at that point we could say that m was going to be equal to 5. We've also now found that the way to differentiate that is just to say y dash is equal to 2x plus 3, and of course when x is equal to 1, like it is at this point here, that would give us 2 times 1 plus 3, which is equal to 5, so that confirms what we found. But we're using some formula that we haven't really proven is true. So we're going to start heading towards a way of doing that. You'll remember when we looked at this particular graph, I got out my magnifying glass and I just focused in on this point here. So what I'm going to do exactly the same process as what I did in that one, but this time I'm using any old parabola or any old curve, in fact any polynomial. I'm going to draw it up and I'm going to put my magnifying glass onto it, and I'm just going to look at the part of the curve that looks like this. Okay, so this is just some function of x. So I'm going to say, in fact I'm going to say y is equal to some function of x. I don't know what it is, but I'm just going to look at it. And what I'd like to know is, what is the gradient of the tangent anywhere on this graph? So I'm going to, actually I might find this point here. Okay, I'm going to find it. I just need to find this point. So this is my point where x is equal to x. Okay, so in this one here I was finding when x was equal to 1 and y was equal to 4. But I'm choosing any point along this curve, so this value here is x. Now when the x value is equal to x, what's my y? coordinate, well, my y coordinate, I have to find it by putting it into the function. So it's just going to be whatever that function is of x. So this, in fact, is the point x, f of x. Just like this point here was 1, 4, because when I put 1 into the equation, I got 4 as my y value. So I'd like to find the gradient of the tangent exactly at any old point along the curve. Now, when we did this earlier, we took another point that was close to it, and then we found the gradient of the line between those 2 points. So I'm going to do that. I'm going to find another point on this curve, and I'm going to say, I'm going to create a line between these 2 points and find its gradient and see what happens. So I'll get my ruler and I'll say this is the line I'm going to find the gradient of. And I know that it'll be kind of close, but it won't be perfect. Because remember, we've got a magnifying glass on this, so these points are very, very close to each other. Now, what's this point here? Well, I'm going to say that this distance here between these 2 points, that the length of that particular distance is equal to, I'm going to call it h, a little bit of height between the two of them. So I hope you agree that that makes this x value here equal to x plus h. I've added a little bit onto it. I've added a value of h, so this is x plus h. What's this point here then? Well, it's the point x plus h, and to find the y value, I have to do f of x plus h. Okay, so this is the point x plus h, f of x plus h. Alright, now I have to find the gradient of the line between these 2 points. You'll remember in that first video, we used our formula from year 10. The gradient is given by y2 minus y1 on x2 minus x1. So my 2 points that I'm using, I'm going to use the point x, f of x, and the point x plus h, f of x plus h. So this will be my x1, y1, and this will be my x2, y2. So what's the gradient going to look like? Let's work it out down below here. M is going to be equal to f of x plus h minus f of x over x plus h minus x. That tidies up a little bit, doesn't it? I could say that m is equal to f of x plus h minus f of x all over h. So these x's cancel out. Alright, so I've now found the gradient of that green line. How does that help me? Well, what we have to think of now, and because you'll remember that when we did this earlier, we kept taking values of x that were closer and closer and closer to where x is equal to 1. So what we're doing is we are shortening this gap here. We are making h smaller and smaller values. What we're actually doing is we're taking a limit as h approaches 0 for this particular formula. For f of x plus h minus f of x all over h. And that's how we're going to find our gradient of the tangent to this function anywhere along that line. So we're saying that y dash can be found by making this value of h shrink to nothing, and that was going to give us our gradient of the tangent. And in fact, I've just dropped my pen. In fact, that is going to be our definition of how to find the gradient of a function. We call this differentiating by first principles. And we're using our principles about finding gradients and bring those points closer and closer together to find our derivative function. Let me show you this in action. I'm going to, and this is going to be the last time I do this because you'll be very sick of this function. I'm going to start with the function of x, which is equal to x squared plus 3. So we already know what the answer to this question is because we use this function a lot. Now, if I'm going to use my new differentiation by first principles, I'm going to have to find what f of x plus h is. Okay. Now, luckily I did that in the warm-up, so that won't take me long and it won't confuse me. Plus 3 times x plus h. Now, at some stage I'll probably have to expand this, so I might as well do it now. X squared plus 2xh plus h squared plus 3x plus 3h. All right, I'm ready to use my formula. So my formula is y dash is equal to the limit as h approaches 0 f of x plus h minus f of x all over h. We know that this is something's got to change here because we can't have a 0 there. So let's substitute our values of f of x. So y dash is equal to the limit as h approaches 0 of x squared plus 2xh plus h squared plus 3x plus 3h minus, we have to be careful here, it's minus f of x, and f of x is all of this, so it's minus x squared plus 3x all over h. Alright, that can definitely be tidied up, so it's equal to the limit as h approaches 0. Do I have to write the limit as h approaches 0 every time? Yes, I do. Until I actually take that limit, I write that every single time. So I've got x squared plus 2xh plus h squared plus 3x plus 3h minus x squared minus 3x all over h. Now here's something lovely. This minus 3x and this plus 3x are going to cancel, and this x squared and this minus x squared are going to cancel. So my next line is limit as h approaches 0 of 2xh plus h squared plus 3h all over h. Can you see it? Got a common factor on the numerator of h. Limit as h approaches 0 of h, 2x plus h plus 3 over h. Lovely. They can cancel. Now I can take my limit. So it's equal to, I'm going to put I'm going to put h equals 0 wherever I see a h. So I'm left with 2x plus 3. And that's exactly what we said was going to happen right at the beginning of our last lesson. No, there it is over there. We already knew that. That was a very long-winded way to get the answer because I told you last lesson that when you have y equals x squared plus 3x, y dash is equal to 2x plus 3x. So it's a very long-winded way of doing it. It'd be great if we could come up with something else, and eventually we will. But being able to differentiate by first principles is a skill that you're going to need to have. So we're going to spend some time now on exercise 7b, and I will put the questions somewhere else because I can't remember which questions we're going to be doing, but we're going to be doing some questions from 7b where we practice finding the derivative using these first principles. I will see you. Bye.